A central angle is going to be equal to the measure that is sub 10, so that's 164. Can someone tell me what y is going to equal then? Megan? 82. How do you get 82?
I divided 164 by 2.
Yep, 164 by 2. Whenever you have an inscribed angle, is half that measure of the arc. Can someone walk me through that next one? It looks like most of us got it right. Either we guessed or we just got it. Like. Okay.
So you know in the top triangle.
Yep.
Like the left angle.
Top left. So we're talking right there.
Yeah.
All right.
And so that's 32.
That is 32.
And the one to the right is 43.
It's 43.
Which means that the tip is 105. Which would make Z 75.
Which would make.
It's on the line.
Yep. Yep, because it's on a line. So we use the fact that this is an inscribed angle. This is an inscribed angle, which gave us the 32, the 43, because it's half of 64, half of 86, and then we just have a triangle, and then we have 75. What I want you to do real quick, if you have a calculator out, type 64 plus 86. Now divide by 2. What was the answer?
75.
And that answer was 70. Do you think that's just coincidence? Sedge doesn't even know what's happening right now. Do you think that's weird? That is the lesson today. That is the lesson today. This one's just basically proving what we're going to do. So our bell work is basically a proof of what we're going to do next. First, we're going to talk about lines again. A tangent line is a line that intersects a circle in exactly one point. So an example of that might just be, let's get a line going on there. That is just one point it hits a line. Secant's going to be a little different. Secant's going to be a line that intersects a circle in exactly how many points? Who wants to take a guess? No one wants to take a guess? Like 6 places. Not quite. Remember, it's a straight line. Could it even hit 6 places? Is the head?
1.
Not 1. That's a tangent.
2.
2. 2 would be a great guess, and 2 is in fact correct. And exactly 2 points. So that an example of that would be a circle, and just a line going through that circle. So that right there is a secant line. All right, the last thing is just a chord. A chord is basically just a segment of a secant. It is a line that hits in 2 places as well, but it's a segment. So the only difference between a secant and a chord is a secant is a line, and a chord is a segment. Otherwise, they're the exact same thing. All right, tangent, secant, chord. Know them, love them. So if I say it, you can know how to draw it. All right. This is exactly what we did for our bell work. We have a vertex inside the circle. So look at those 2 secant lines. They intersect inside the circle, and they create angles that are inside the circle. If 2 secants or chords intersect in the interior of a circle, then the measure of the angle formed is going to be half the sum of the measure of the arcs intercepted by the angle and its vertical angle. So if we look at number 2, if I needed to get the measure of angle 2, I would find BC, I would add it to AD, and then I would divide by 2. If I needed to get 1, I would do AB plus DC, and then divide that value by 2, and that would give me 1. It also gave me these because they're vertical angles, so it gets you both of those top and bottom angles. So that is your formula for if they intersect inside a circle. So some examples. We have our first one. What is the value of G? Well, you're going to ask yourself, is it two lines intersecting inside a circle? Yes, it is. So that's when you're going to do your 1/2 your two arcs added together. Well, that's going to be G is going to equal 1/2 32 plus 32. I should have really changed, did I? Yours are 32 and 32, right? Well, no, it should have been different. Anyway, that's going to give me G equals just 32. Because it'd be 64 divided by 2, so it'd be G equals 32. For our next one, I'm looking, we have two lines that are intersecting inside a circle. So that means the measure of the angle equals the sum of the two arcs. So that means 75 degrees is my interior angle. That's going to equal 1/2 my two arcs added together. So that's 100 plus x. What I'm going to do to get rid of that 1/2, I'm going to multiply both sides by 2. Are we all okay with that? Otherwise, I have x over 2 and I have to multiply it later on. So I'm going to multiply both sides by 2. So it'd be times 2 on this side, times 2 on that side. And we're going to have 150 equals 2 times 1/2 is just 1, so we're just left with 100 plus x. Subtract 100 on both sides, you can come up with 50 degrees equals x. What I always do if I'm doing it this way, I would just go, okay, 50 plus 100 divided by 2. Yep, that's 75. I got the correct answer. Don't get lazy. Don't get lazy with checking your answers. It's really, really quick, and it can save you points on a test. All right, this is what happens if two lines intersect inside a circle. Oh, I had more room there. Cool. All right, the next thing we're going to talk about is what happens if they intersect outside of a circle. What happens if they intersect outside of the circle? So if two secants, a secant and a tangent, or two tangent intersect in the exterior of a circle, then the measure formed is half, once again, but this time it's going to be half the difference of the measures of the intersected arcs. Be careful on this one. This one isn't so bad because you can always see they're intersecting inside of a circle. These can be a little more complicated because, like I said, you can have two secants. That's this one. You can have a secant and a tangent, and you can have two tangents. When you are subtracting, you always subtract the bigger or the smaller number from the bigger number. So if you're ever confused at which arc is which in this sequence, it's always going to be bigger minus smaller. Otherwise, you're going to have a negative angle, which isn't going to make sense. So in the two secants lines, DE would be your bigger, BC would be your smaller. So you do DE minus BC. With a tangent and secant, once again, it's the opposite arc minus the inside arc. And finally, if we just have two tangents, it's going to be the outside arc minus the inside arc. Big minus small. Inside, you add them. Outside, you subtract them. So some examples. Our first one is solve for, is that H? So tiny, so tiny. We need to solve for H. Well, I'm going to say, okay, H is an angle outside of the circle, so that means I'm going to use subtraction. So we're going to say H equals 1/2 the bigger or the outside arc, which is 86, minus 32. Well, that's going to be 54 divided by 2, which is going to be 27. Whereas H equals 1/2 of 54, which is going to go ahead and equal 27. All right, our next one, I'm supposed to solve for n. Well, remember, it is the angle. This is what's going to trip people up on the test. It is the angle equals 1/2 the arc minus the arc. Both your arcs are on the same side. So in this case, we're going to have 17 degrees is going to equal 1/2 your big arc, which is your outside arc, minus your small arc, which is your inside arc. Once again, I'm going to start with multiplying both sides by 2. So I can get rid of that 1/2. You'll have 34 equals 76 minus n. Well, I will subtract 76 on both sides. Oh, did I not do that on this one? Whatever. And we're going to have 42, negative 42 equals negative n. Multiply both sides by a negative 1, and you're going to come up with n equals a positive 42 degrees. Not a bad idea to check 76 minus 42 and divide by 2, and you should come out with 14. All right, go ahead and do the last two. Do the last two. You should come up with, on this one, you should come up with J equals 34. And on this one, you should come up with D equals 40 degrees. As soon as you get that, let me know, and then we'll go over homework questions. I'm just going to go over any homework questions. Yeah, Tyler. 23. Let's see if I got the right ones out. Excuse me. All right. So we have an equilateral triangle ABC is inscribed in a circle. So let's make a circle. Let's make an equilateral triangle as best we can. Yes, we can. That looks almost equilateral-ish. And that's equilateral ABC. A, B, C. All right, F, G, H, I, J, K. P and Q are midpoints of BC and CA respectively. So we have a midpoint here. Cancel. We have a midpoint. No, make a midpoint. Jerk. There we go. And those are going to be P and Q. Respectively, what kind of figure is quadrilateral AQPB? So let's highlight that in red, what we're talking about here. So we're talking about, what is this shape? First of all, what does it kind of look like?
Oh. I need to update.
Thanks. The problem is every time I update my computer, it takes forever. What kind of shape does it kind of look like, Tyler? It kind of looks like a rectangle, but we don't know for a fact yet. We can actually prove it's a rectangle. What's the measure of every angle inside an equilateral triangle? They're all equal. 60 degrees. Yes. 60 degrees would be a much better answer. So we'll make, let's look at angle B. B is 60 degrees, correct? Okay, so that's 60 degrees. All right, if that's 60 degrees, that would make, can you picture this inscribed angle? Do you see that inscribed angle? So what would the measure of ACB? Not 180, but 120. Yes. So A to C would be 120 because it's twice 160. Well, remember this part. It said that Q was a midpoint of AC. So that means it cuts this arc in half. So that means each of these arcs, so AQ is 60 degrees. QC is 60 degrees. And if we did this exact same thing with angle A you agree is also 60 degrees, right? And then this would be 120, and this would be 60 and 60. Does that all make sense? All right. Now here's the whole part of breaking these up into 60 and 60 degrees. Well, 60 plus 60 plus 60 is going to be 180. Well, look at the inscribed angle ABP. That's that arc 180. So what's the measure of angle B? If the arc is 180, what's my inscribed angle going to be? It's going to be 90 degrees. So B is 90 degrees. And then A, following that exact same thought, would also be 90 degrees, correct? And then opposite angles of an inscribed quadrilateral are, yep, so supplementary, so that'd be 90, that'd be 90. Now I know for a fact it's an it's going to be a rectangle because all the sides are 90 degrees. That's by definition a rectangle. Does that make sense? Awesome. Other questions from the homework? That's kind of a clever little problem. Other questions, though? Other questions? Going once? Going twice? Sold to the highest bidder. All right. Then the rest of the time is yours to work. Yours to work.